So we learned yesterday that there is a theorem that lets us solve for missing sides of triangles. But what kind of triangle does it have to be?
Right.
It has to be a right triangle. No right triangle, no Pythagorean theorem. So this says, given a right triangle. So on your warm-up page, if you did not draw a right triangle, draw one right now. Go. If you did not draw a triangle with a right angle, do so right now. This little symbol right here indicates that it's a right angle. Indicates that those lines are perpendicular. Okay. The hypotenuse is 14. How do I know which one the hypotenuse is? What did you say, Steve? It's the longest side. And if you're not sure which side is the longest side, then you just look away from your right angle, and that would be your hypotenuse. One leg has length of 5. So we'll put 5 here. So this is our x. This is our missing side. You can call it b. You can call it x. You can call it a. I don't care what letter you call it, because a letter is just a variable, and it doesn't matter. All right, so yesterday we learned that Pythagorean theorem says a squared plus b squared equals c squared. So if you haven't written that on your warm-up sheet, make sure you show your work to get full credit. Make sure you show the equation. Now, unfortunately, I can't take the square root of anything yet because x is not by itself. How can I get x all by itself? Let's move the 5 over. Good suggestion. How do you move something that's being added? What's the opposite of adding? Subtracting. So, x squared equals 14 squared minus 5 squared. So if you did 14 squared plus 5 squared, that's where you went wrong if you showed me your answer and got it wrong. So we do 14 squared minus 5 squared, and be used to grabbing your calculator every day when you walk in. X squared equals 171, and we know that the last step of Pythagorean theorem is always square root. Very good. So we're taking the square root of 171. Make sure you know where the square root button is, super important. And it did not say what to round to, so you might have put 13.1 or 13.08. Those would be rounding correctly. That's to the nearest tenth and to the nearest hundredth. Mary wants to grab lunch at Wendy's, then go to the mall, and then head home in time for dinner. How much shorter would her trip be if she just went straight home from Wendy's and didn't go to the mall? So, step 1, let's find what her path is. If she goes to the mall, or sorry, where are we going? To Wendy's and then to the mall. She went straight home from Wendy's. Okay, so she's at Wendy's. This is where we are. We are at Wendy's. Are you going to let me write on it today? Yep. We just had lunch. We're nice and full. We ate some really bad fast food for us, but that's okay. We splurged. And so we're trying to decide, should I go home this way, the green path, or should I go home this way, straight home, direct line, straight distance? So let's find out how long it would be to go the green path way, and then let's find out how long it would be to go the blue path, and then how much shorter. What are we going to do? Subtract. We're going to subtract. So a lot of you found the blue path, and that was just your answer. And I'm so glad that you did Pythagorean theorem, but you didn't read the problem. So, green path. This is not here. Seth, how far did she go if she took the green path? Do it in your calculator real quick. Or by 2.3 and 7.9. 7.9. Mm-hmm. Oh, 2.3 and 7.9?
Oh.
2.3 and 7.9.
But this time you may close your doors. Thank you.
Yes! Okay, so she went 10.2 miles if she decided to go shopping at the mall or meet her friends at the mall. Okay, how far is it? Oh, that's not here. Jonathan, how far if she went straight home? 8.22? And don't put squared. Oh, I'm glad I caught that. Okay, so if she went straight home, he says the blue, if you did Pythagorean theorem, it would be 8.22. Is that what y'all got to? 8.22. Cool. All right, and then we're not done. We have a long way and we have a short way. So now it says how much shorter. Everyone in class find out how much shorter. Every person on your calculator. How much shorter would it be if she went straight home? That is a subtraction problem. How much shorter? I'm going to call on Trinity. What's the answer? 1.9, or you could round it to about, she'll save about 2 miles. So I'll accept both of those answers for the people who didn't turn it in. Solve for X, show me on your whiteboard. Round, let me tell you what's round here. Round to the nearest tenth, which means 1 decimal place. Give me 1 decimal place. Hold it up. That's right, but you need to round differently. Good. Awesome. Round to the nearest tenth. So try again. Round to the nearest tenth. Nearest tenth is 1 decimal place. I didn't say to the nearest tens, nearest tenth. Good. Good. There you go. Good. Very nice. Once you do Pythagorean Theorem enough, you'll get used to, oh, if I'm looking for a leg, I subtract. If I'm looking for a hypotenuse, I add. So I could just start off by doing this. 15 squared minus 8 squared. I don't have to set up the a squared plus b squared equals c squared and then move the 8 over. You don't have to do that step every time once you get used to the fact of, oh, I'm looking for a leg. That's going to be smaller, so I'm going to subtract. So in your calculator, you're really just taking the square root of 15 squared minus 8 squared. And the answer was 12.7. The answer was 12.7. I do need to remind you what we did yesterday because we kind of were rushing at the end of class because we were running out of time. So what I showed you at the end of yesterday was that there's a formula. It is called the distance formula. And the distance formula comes from Pythagorean Theorem. They're actually not two different things. They're actually the same thing but in different forms. So if on a graph I said, find the distance from A to B, what you're never going to do is just count boxes because you're not allowed to count diagonally. Thank you, Jonathan. You're allowed to count vertically. Go for it. You're allowed to count horizontally. Go for it. But you are not allowed to count diagonally. So when I do give you one that is diagonal, you can turn it into a triangle and you can use Pythagorean Theorem. Or you can use the handy-dandy distance formula. Let me show you where it comes from. So you start with Pythagorean Theorem. This side is, I'll call this A, and this is B, and this is C. So we already know this. A squared plus B squared equals C squared. We already know that. Now, if you notice, did I do those correctly? I kind of switched them, but it doesn't matter. A is the change in Y. You saw that in algebra. Delta Y means the change in Y. So A is like this length right here, and B is the change in X. It's the horizontal length. Are we allowed to count A? Absolutely. Are we allowed to count B? Absolutely, if we had our little squares. So I put those in there. That's what those are. And then in the picture, I put them in there. So the change in X would be the X minus the X, and the change in Y would be the Y minus the Y. So now this is still Pythagorean Theorem. See how it's still A squared plus B squared equals C squared? What do you always, Yasmin, do last in Pythagorean Theorem? What's always the very last thing you do in your calculator? Opposite of squaring. Starts with an R, square, root. Yes. So you always end up square rooting. And so if I took this and I square rooted it, then da-da-da, that right there is the distance formula. So that's kind of what we did at the end of yesterday. And then the bell kind of rang and we were rushed. So the distance formula is, if you like this one better, use this one. If you like this one better that tells you exactly where to put things, then you can use this one. These are the same formula. On this one it says delta x, but delta just means subtract. So these are the same thing. All right, on your whiteboard, I already showed you that. On your whiteboard, I want you to find the distance between G and H. Go. On your whiteboard, find the distance between G and H. Did I talk yesterday at the end of class about the template, about the empty one? Start with an empty one. Start with an empty one, just like that. I'm going to give you a second to put that on your whiteboard. Copy this onto your whiteboard, an empty distance formula. Nothing, no numbers filled in, because the numbers get confusing. And then a trick is, you can come over here to your coordinates. You can circle your x's and underline your y's. And the reason you would do that is because then you can just take both your circles and put them together in parentheses. And then take both your underlines and put them together in parentheses. So I'm going to put circle, circle, and then I'm going to put underline with underline. And then honestly, after that, you can let your calculator do the rest of the work. The only way you can mess up this formula is just by getting the numbers mixed up. A minus and negative is a plus. So you can put plus or you can put minus negative in your calculator. This is the minus sign, and that's the negative sign. It lets you do it. Ask me a question about how I got 8.6. If you did not get 8.6, ask me a question. Yeah? We can do this. You can do the distance formula. It's like exciting stuff, right? This distance formula. Okay, try another one. Try that one. Find the distance between the points to the nearest 100. This time, that's 2 decimal places. I'm going to draw the template for you while you're still getting used to it. Do you have to memorize the distance formula? No, you actually don't. I thought I said that yesterday. You do not have to memorize it. You just have to know how to use it. You do not have to memorize it. You just have to know how to use it. I need to see that you can make sure that you know. Oh, go get your assignment calculator, whichever one you remember. Just post it up there just in case you forgot. You can't do distance formula without a calculator, unless they're perfect squares or something. Ooh, you got a whole number. Let's see. Let me see. 9 minus 5. Oh, you did. It should have been -1 minus, what does that number say? -2 minus -2. So do one less decimal place. Here's 100 is 2 places. Okay, y'all got different answers, so that's not good. Yes, that looks, well, yep. So remember, circle, circle, underline, underline. You can't change the number. You can't change it. So I'm going to stick 9 and 5 here. Ooh, you're writing so small. And I'm going to stick -1, and be careful. Is everyone watching? I do not put a 2 here. I put a -2. That's a lot of negatives in one parenthesis. Your calculator knows what to do with them, though, so don't worry about that. Remember, this is the step you don't have to do, but you can if you want to make it look pretty first. 9 minus 5 is 4. And -1 plus 2 is actually 1. Look how pretty, how quickly that gets pretty. The square root of 4 squared plus 1 squared. So you should have gotten the square root. 4.12. 4, oops. It's trying, oh, it opened the calculator, yay! Okay, you get it. Got it, okay. So 4.12 was the final answer there. 4.12. Okay. That's all that we're going to do, going over the distance formula, because the rest of it you can do on today's practice. I don't even really love the distance formula. I try to avoid using it unless I absolutely have to. So the only time you have to use the distance formula is when you don't have a picture. when I just give you 2 points and I say find the distance. But guys, because this is going to be on your assessment on Thursday, if you're given a picture and it's in a coordinate plane, don't use the distance formula. What do you use instead? Pythagorean Theorem. Let's say you were trying to find CD. Turn CD into a right triangle and count. If I were to count, John, are you watching? You're not even looking at me. If I were to count, this leg is what? 2. This leg is 1, 2, 3, 4, 5. And instead of the distance formula, you're going to do 2 squared plus 5 squared, and you're going to take the square root, and it's over. You're done. And you don't have to worry about all those points and all those messy coordinates, okay? So you only use the distance formula when it's a last resort, when you have to. All right.